This video is going to show you how to write equilibrium expressions properly. And if you're given some equation like this right here, notice we write them as two arrows showing a forward reaction and a reverse. This one is just showing the two arrowheads on one arrow, but the idea is this reaction is in equilibrium. We can write an equilibrium expression to calculate the equilibrium constant Kc. And you'll notice it's always the concentration of the products. So I have the concentration of C raised to the C's, its coefficients, power, times the next product to the coefficient as a power, divided by the same thing for your reactants. So whatever the concentration of A and B are, raised to the power of whatever their coefficients are. So these things, anytime you see stuff in brackets, it represents the concentrations in molarity. And for equilibrium expressions, the concentrations have to be at equilibrium. And the lowercase letters happen to just be the coefficients in a balanced equation. So they're really easy to do. You only put gases in the expressions. You don't put solids and liquids. Let's try this example down here. Notice all of these are gases, so they will all go in the expression. So my equilibrium expression, KEQ, or sometimes Kc, the equilibrium constant, is found by writing the concentration of my product. In this case, I only have NOBr, and that will be raised to its coefficient as a power. Well, this 2 here means I'm going to square it, divided by the same thing for my reactants. Well, I've got 2 reactants, so it's the concentration of NO squared times the concentration of Br2, and it doesn't have a coefficient, so it's just raised to the 1 power. So if I knew what these concentrations were, I could actually just plug in those numbers and come with an answer for whatever my equilibrium constant would be. Notice the denominator, you do not add them, you multiply them. NO, the quantity squared, times the concentration of Br2. If I had something like this, H2 plus Cl2 in equilibrium with HCl. And let's make these gases and this a liquid. You get a 2 there to balance it. To write my equilibrium expression, we only include gases, which means my products, there's really nothing there, so you put a 1 on top. And on the bottom, I have concentration of hydrogen to the 1 power times concentration of chlorine to the 1 power. That would be the answer for this equation. Again, notice we only include gases in the expression.